Following on from the lesson on the factor theorem, we're now going to look at dividing polynomials like cubics by using algebraic division. We're going to look at three methods. First of all, at using inspection. Secondly, at the long division method. But we're going to focus mainly on equating coefficients, which is usually found by most students to be a more sympathetic method of this quite difficult procedure. Let's have a look at dividing numbers first. Say dividing 7 by 2. Well, we know we get 3.5. And we can write this like this. We call 3 the quotient, the whole number element. We can basically get 3 lots of 2 in 7, and there's a bit left over, isn't it? And the bit left over we call the remainder, which is 1. We do a similar process with algebraic expressions. So for example, if we're dividing x cubed plus 1 by x squared, we could again split it up like so. X squareds into x cubes gives us just x, doesn't it? It's x times x times x over x times x. So 2 lots of x is in the numerator and 2 in the denominator cancel, leaving just x, plus 1 over x squared, where x is the quotient and 1 is the remainder. Another example, again we can split this up. We're quite often asked in questions to split expressions up into a certain form. And here we're given the form a, where a will be an integer, plus bx plus c over x cubed. So again, if we split it up, we get 2x cubed over x cubed, which will cancel down to 2, won't it, with the x cubes cancelling, plus 3x minus 5 over x cubed, where 2 is the quotient and 3x minus 5 the remainder. Okay, now it's your turn. Find the quotient and remainder from question 1 and write this out in this form here. Pause the presentation, have a go, and then check the answers. Okay, the solution to the first one, split it up like so. X into x cubed is x squared, x into 7x squared, well this x will cancel, we'll lose the squared, minus 4 over x. This part being the quotient, and the remainder is the minus 4 here. Again, we can split this up in this way here. We end up with x there, 2 here, and then this remains here with minus 4x minus 3 as the remainder. Well, we're going to show 2 ways of doing this. The first one is the long division method, and to do this we set it out like so. And we then divide the first term here that we're dividing into by the first term here. So we get 2, and we place this above here. What we then do is we multiply this expression by 2. And we get 2 times x minus 1 gives us 2x minus 2. And we subtract that because at the moment we've got two lots of x minus 1. This is what we started off dividing into, so we want to see what we're left with. 2x from 2x gives us 0. Well, if this bit didn't give us 0, we would have done something wrong. So this bit should always be 0. And then 6 minus negative 2 gives us 8. We can't divide x into 8, so this is just left as a remainder. So 8's the remainder, and we just write it as 8 over x minus 1. So the quotient is 2 and the remainder is 8. Okay, the same problem using a different method, the method of equating coefficients. We write 2x divided by the first term x, and we get 2. Here we need to generate x, so we place the 2 there. So on the left hand side we've got 2x plus 6. On the right hand side we've got 2x minus 2. So the first term's correct, but the constant term we need plus 6, we've got minus 2, so here we need plus 8 to make the right hand side equal the left hand side. And there we are. We can now cancel the x minus 1's in this first term, but we can't here, so we leave this as 8 over x minus 1. So we separate the two terms like so, cancel the x minus 1's, and we get a quotient of 2 and a remainder of 8. Method 2 tends to be more sympathetic with harder divisions. For example, dividing 2x squared plus 5x minus 3 by x minus 1, we write it out using the denominator in our top line. Well, the first term we need to generate is 2x squared. So here we need 2x. We now get on the right hand side 2x squared minus 2x, but we've got plus 5x on the left hand side. So write out another x minus 1 here, and this x term needs a constant with it. We've got minus 2x, we need plus 5x, so we need a plus 7x there. So plus 7 goes there. We now have the first two terms correct, but we've got minus 7 and only minus 3 here. So to correct the last term, we place plus 4 at the end. And now the right hand side equals the left hand side. You can see there that if we multiply out everything, we get back to where we started, which is what we'd expect. So splitting our three terms, we end up with x minus 1's cancelling here, leaving 2x, x minus 1's cancelling here, leaving plus 7, and here we've just got plus 4 over x minus 1. So we get a quotient of 2x plus 7 and a remainder of 4. So the procedure, write the denominator on the top line, correct the first term. Copy the denominator and correct the next term. Correct the last term. Check the numerator to make sure when it's expanded out it makes the same thing as on the left hand side. And then split it up into a quotient and a remainder. Finally, we'll have a look at this cubic here. We're dividing this by the linear factor x minus 1. You'll notice here we don't have an x term, but we're going to leave a space there so that when we do our working out, it's clear what's going on. We're going to treat this like 0x. So the first thing we do then is we generate our x cubed term, and as we've just got 1x cubed, we need x squared in there. So the first term's now correct. We then put the denominator in again. Now we've got minus x squared here and minus 2x squared here. So we need something in here to give us another minus x squared. So we need minus x, don't we? So we've now got minus x squared minus another x squared, which gives us our minus 2x squared. We now need another x minus 1 to generate 0x here. We've actually got x here because we've got minus x times minus 1, but we actually need no x. So we are going to need here an x term to compensate. So because we've got plus x on the right and no x on the left, we need minus x. So it's just minus 1 that goes in there. We've now got our first three terms correct. We've got plus 3 here though, and plus 1 here. So we need a plus 2 tagged on the end to make everything equal. If we then cancel the x minus 1's, we end up with x squared minus x minus 1, and then the remainder is 2. So we write that as 2 over x minus 1. Okay. Right, now your turn. Have a go at these two. Pause the presentation, have a go. If you're successful, then you're ready for the lesson. Okay, this is what you should have got for the first one. Working through the process, split everything up. Quotient of x plus 2, remainder of minus 8. For the cubic, work through it, correcting the terms as we go through. And we should end up with a quotient of x squared plus 2x minus 6 and a remainder of 7.